Thank you. All right. It is February 8th, and it's just a month more, and we're done with our class.
Oh, wow.
Yes, so I'm glad we're done with midterms. As I mentioned that I really gave midterms so that your end of term exam will just be covering whatever we will be discussing starting today until our last lesson. So I'm not sure if you have questions uh, on the midterms. Just want to remind when many in some areas you're being careful on what you're doing. Sometimes you miss a few things. So really, it's being careful in doing things, not missing those small things that's required. Okay, so yeah, you can in the process. Yes, we spent a lot of time dealing with algebra essentials. Reason is because those that what we have learned will continue to be used in our discussion in these future discussions. So we will continue with our discussion on equations. And as I mentioned, the fact that algebra is the science of equations. We will, in almost all areas, solving problems would really be dealing with equations. So today we will begin. We dealt with computing algebraic terms, computing equations, but we just want to relate algebra with real world. So our discussion will be on the first part of our discussion will be we call models and applications, where we have to say it simply, we will be dealing with word problems, trying to have some real world applications of algebra. And yeah, we call that mathematical modeling. That's the big term, right? But really in algebra, it's just word problems. We want to use math to solve real world problems. And so there's a problem, then you try to analyze the description and think how you can model it and transform that into what we call an algebraic expression. And of course, we can interpret the solution, making sure that the solution would be fully understood as something that is within the real world. And so the simplest thing that we will be considering as far as models and applications are concerned would be our linear equation. And so you said you're enjoying solving linear equations. We'll continue to enjoy solving linear equations in this first part of our lesson this morning. Okay, so yeah, but for us to be able to translate the verbal model in our mind into an algebraic expression, we need to remember that algebra is a language. And so there are English phrases that we should transform into mathematical language. And so some terms, and it's not difficult because we are uh, very familiar with the English language, so that the English phrases that would be associated with these mathematical operations. Okay. So whenever you see these terms and maybe any related terms, then change, like you say, the sum of, added to, increased by, plus, more than, greater than, exceeds by, more, then those phrases or the word, you will just change that into a plus. Okay. When you see the difference of, diminished by, decreased by, minus, subtracted from, less than, take away, less, then change those phrases to the symbol minus, right? The product of, multiplied by, of, times, twice, thrice, or 4 times, whatever. So the word of is take note. Once you read the word of, that is associated, that can be translated as times or multiplication. Yes. And the quotient of, divided by, all over, ratio, into, or split into, then that would be the symbol of division. We divide. And you say square, cube, that would be raising to a power, which we call exponents. So we'll get used to this different phrases, so we're able to translate the English into mathematical symbols. But one thing with addition and subtraction, uh, we should be very careful about the order of the number, although in addition it may not be really very, very crucial, because we know that addition is commutative. But it's just nice to know that when you say 5 more x, then it should be 5 plus x. But when you say 5 more than x, then translate it as x plus 5. Of course, 5 plus x and x plus 5, they're just the same, so that's not a big worry at all. You say 5 added to x, it should be x plus 5. 5 greater than x, then it's x plus 5. So the only time we say 5 plus x, then we say 5 more x, right? Now, it's crucial with subtraction because it's not commutative. So once you see 5 less x, that is 5 minus x. But when you see 5 less than x, it should be x minus 5, all right? So 5 minus x is 5 less x. 5 less than x is x minus 5. And of course, you say 5 subtracted from x. And I think that's easy to see. You subtract 5 from x, so it should be x minus 5. But whenever I would say the difference between a number and that between a number and 7, then you just have that as x minus 7. Yes. But it's now the 5 less x and 5 less than x, or 5 subtracted from x. So let us be careful, because once we interchange, then that would already be a different algebraic expression. Okay, so those are the things. Now, just a little practice. So yeah, so whenever we have, let me use my pen. So you can now answer. When we say the sum, let us try, let our value x, okay, we can say n or x or whatever, because like we'll have a constant and we have a variable. So in most cases, of course, we use x because it seems that x is something that is unknown. Yeah. So when you say the sum of a number and 9, how will that be translated?
X plus 9
All right, so you now have x plus 9. The difference of a number and 21. Difference.
minus
All right.
21.
So I said just use that you begin with the number difference, okay, of that number and 21. So you say x minus 21. The product of a of 6 and a number.
6 times n.
All right. So it's 6 times x, or you can just say 6x.
Mhm.
Yeah, because it's, the times may not be there anymore. So 6x. The quotient of 48 and a number.
48 divided.
Right. So I'm just using, in this example, I'm using the terms for the result when you use addition, subtraction, multiplication, division. So you now say the quotient of 48 in a number, that's 48 over x. And of course, 1/3 of a number. Then the word of is associated with multiplication. So 1/3 of a number, just say 1/3 of a number. The number is x, all right? So 1/3 of a number.
Oh, x times 1.
Yeah, it's 1/3 of 1/3, okay? Of is multiplication, all right? So it's 1/3 times x or you can just say 1/3 x. So take note of that word of. That is associated with multiplication. All right. So anyway, we'll be having a few more of these exercises. So if I said n, but I wanted x anyway. All right. So once we have as we are dealing with linear equation, the problems, of course, would mean that you can translate it into an equation where we interpret the words that you see in a problem as mathematical operations. So you always assign a variable to represent the unknown quantity. But it's important that you should know what's given, what are the given numbers in the problem. Then we assign a variable of what is unknown. And in our problems here for linear equation, it will just be one variable. You can use x, r, t, or whatever. Yeah, and then we write an equation to interpret the words as a mathematical operation. So because it's now equation, there must be an equal sign. So these are the terms that you need to watch out that you can translate to equal. And of course, the word equals, or you say gives, or is. When you see the word is, or if it is a problem that deals with the past, you see was, or for the future, then you see should be. So is, was, should be would be equal. Yields will also be equal. Amounts to, that's equal. Represents, that's equal. Is the same as, that's equal. And any related terms that you can translate as equality. Okay, so an example. All right, like when I say 6 more than 7 times a number is 34. It's 34. I have written 3. I'm sorry about that. That should be 34. All right. 6 plus 7x equals 34. So 6 more than is plus, 7 times is of course multiplication, a number where your number is x, is equal, and then it's equal to 34. So then you can solve for x, and you already know. So just looking at it, what will be your x?
4.
All right, yeah. So you now have 7x is equal to 34 minus 6. 7x is equal to 28. So that x is equal to 4. So computing, that's not a problem because you already are very, very familiar with computing equations. Okay. All right. And so let's try here. The product of twice a number and 3 is the same as the difference of 5 times the number and 3/4. How do we write that in symbol? Okay, okay, I'm sorry. I don't know why my sharing went away. Okay, let me share again. All right, there. The product of, all right, is times. So you say the product of twice a number is 2x and 3. So the product of twice a number and 3 is 2x times 3 is the same as, that's equal. The difference of 5 times the number, which is 5x, minus 3/4. The difference of 5 times the number and 3/4. Okay, so that's the way it should be. So therefore, our equation is 2x minus, okay, sorry. Why did I put? Okay, let's go back. All right, so our equation is now 2x times 3 is equal to 5x minus 3/4. So final equation will now be 6x is equal to 5x minus 3/4. Yes. So you isolate the x's as you have known already. So 6x minus 5x is x is equal to minus 3/4. And that's easy. So 6x equals 5x minus 3/4. Okay. All right. So I want each one of you to, I'll show some samples here. Let's begin with this. Okay. 5 more than twice a number is 43. Manish, how will you translate that to an algebraic expression? That's a sentence. Then we change it. 5x, 5 more than twice a number is 43. Okay, so you always say let x is equal to the number.
So 2x plus 5.
All right, so you say 2x plus 5 is equal to 43, and x is?
2x is 38. X is 19.
Okay, 2x is 43 minus 5, which is 38. X is equal to 19. Good. Okay.
May I ask,
Yes?
you said 5 plus 2x is wrong?
It's actually not. As I was saying, it's not very crucial because that is commutative. But really, if you really want to translate 5 more than twice a number, it should be 2x plus 5. But even if you write 5 plus 2x, that would be still okay. All right, how about this? A number decreased by half of the number is 4. Sine?
A number decreased by x minus
A number decreased by
half of the number. Okay, it's 1 over 2x.
Okay, where do you start? Will you begin with x or 1 over 2x? A number decreased by half
X.
of the number. So the number is represented by
X
x. All right. Decreased by
minus 1 over 2.
minus half of that number.
1 over 2x.
All right. Is 4. Is that okay? Yes. A number decreased by half of the number is 4. So what will be your final answer?
X minus.
So x minus 1/2, that will be actually 1/2 x, right? Because it's x minus 1/2 x.
Yeah.
1 minus 1/2 is equal to 4. So x is?
8.
8. All right. So 8 minus 1/2 of 8 is 4. Okay. Because that's 8 minus 4. Okay, let's have another one. Bethany.
2/3 of the sum of 3 times a number and 6.
2/3 of.
3.
2/3.
Does 2/3 come first?
Okay, yes, because it's 2/3 of. All right, so we begin with 2/3. Yes, so 2/3 of. The word of is?
Multiplication.
Multiplication. Then it says, so we multiply that. That second one seems to be a binomial because it's the sum of 3 times a number and 6. So I'll put a parenthesis to show multiplication. So how do we write? The sum of 3 times a number and x. And 6, I should say. Where, of course, our x is the unknown number. So the sum of 3 times a number.
3x plus
3x plus 6. All right?
plus
Is
10.
10. Okay. So what will be our answer?
Oh.
Yeah,
Yeah, immediately, because the 2/3 is a common denominator of the whole algebraic expression. And I think we learned that we can just do what we call cross multiplication, right? Okay, I'm sorry. You can talk of 2 times 3x plus 6 is equal to 30, correct? So I can just multiply the whole thing by 3. So that 3 will now be taken out. Yes, so 3 times 3. Okay, so you now have 6x plus 12 is equal to 30. 6x is equal to 30 minus 12. 18, okay, and therefore x is equal to 3. So you can always check your answer. So 3 times 3 is 9 plus 6 is 15 divided by 3 is 5 times 2 is 10. Yeah.
Also,
All right.
2, 3
Question?
times.
All right. How about this one? Twice the difference of a number and 3 is 4 more than the number.
Twice.
The word
Two.
twice is
2 times.
what number is associated with twice?
2.
2. Okay, 2. The difference of a number. So when you say twice is 2 times something, right? So you put a parenthesis because I'm now dealing with the difference of a number and 3. So how do we write that? The difference of a number and 3.
Minus 3.
Okay, so that number is x. So put that as x. That number minus 3 is 4 more than the number. Just to put that in perspective, you can make interchanging, but it's not a problem. But how do we really write 4 more than the number?
Plus 4.
Okay, so it's x plus 4. Mental math, what's the final answer?
2x.
10.
10.
X equals 10.
X equals to 4 plus 6, 10. Yeah.
All right. Yes, I am allowing you to do some mental math. Yes. So 2x minus x is x. 4 plus 6 is 10. Okay, so those are some of the so we just get used to those terms, those phrases translating to mathematical symbol. Okay, now there are times when there's more than one unknown quantity. Okay. And so the fact that we're dealing with linear equation, we only should express each of those unknown quantities in terms of one variable. So we find a way to write the second unknown in terms of the first unknown. Just like when I say one number exceeds another number by 17 and their sum is 31. Find the two numbers. So I already have the solution there. Let's just analyze. Okay, so we're looking for two numbers. And so we would want to represent the first number as x. And it says the second number exceeds the first by 17. And therefore, if the first number is x and the second number exceeds the first by 17, then we can write the second number as x plus 17. Okay. And the sum of the two numbers is 31. So we now write x, this is the first number, plus x plus 17, which is your second number. The sum is 31. And then we just simplify. So you now have 2x plus 17 is 31. 2x is equal to 14. And of course, our x is 7, such that If x is 7, the other number will be plus 17, which is 24. So we now have 7 and 24, and we know that 7 plus 24 is 31. Okay, so that's always looking at, we always represent one and then represent the other, okay, in terms of that first, which we usually write as x. So let x equals, and then look at the words there and see how you can represent the other unknown quantity, okay, in terms of the other quantity. Isn't that interesting?
Can you please wait?
It's okay. All right. You now can reflect.
One number exceeds another number by 17.
The second number exceeds the first by 17. One number exceeds another number by 17. So your one number, let that be x. Okay? And that number, which is that second number, okay, exceeds that x by 17. So when you say exceed, it is understood to be addition. It's like more, all right? More than, the number more than 17. Of course, you can put 17 plus x. That will still be okay. But, you know, it's just good to put x plus 17. One number exceeds another by 17. You know, it's tricky. You know how English is. They say that English is a crazy language. Sorry to say that, but that's how it is, you know, the way they say things. And me being not a native speaker, sometimes I myself, sometimes I even misinterpret, because my thinking is the way you write it. You know, I write it a Filipino way kind of thing, but we just have to be mindful of how English construction is done. Yes. So one number exists. So maybe whenever I make a problem, especially for your quizzes, I will make it so simple that we will not anymore get confused on how how it is done. But that's how it is. One number exceeds another number by 17. So I'll write it the Filipino way, or maybe you will not understand because my Filipino English may be different from South African English, or maybe different from any Asian English, or I don't know. Anyway, so is that okay? One number exceeds another number by 17. And so that's only saying that the relationship between that number and the other number is that one of them is 17 more than the other one. So that's the meaning. One number exceeds another by 17. You're dealing with relationship between those two numbers. This is one number. The other number is 17 more. You got it? Okay. And therefore, the sum of that is 31.
The entire equation is solved to find the first x.
Yes. Then you can solve for the other x using your representation of the other number. Okay? So if
Okay.
your x, what you will find is your x. And then you can get the second number based on how you represented that second number, which we wrote as x plus 17.
The first number is 7, then the second is 17 plus.
Yes, that's how it is. If ever that happens, yeah.
Okay.
Yeah, but because of the condition that the sum of the two numbers is 31. Okay. Yeah, don't worry, we will have. And what I plan to do is whenever I give an assignment or something, I'll choose the odd numbered items so that you have an answer in the appendix, and you now have the idea and just learn how to go about it and get the answer. Okay? Yeah, I know this one is all right. Now, Don't worry, we have a few examples here that we will be dealing with. Let's now deal with, the word consecutive, dealing with integers. You've done this in high school, okay? Where you talk about the sum of 3 consecutive even integers. I'm just giving some examples here. And so when you talk of, there are now 3 that we're looking for. So if we let x be the first even, and I think you know that when you talk of even, the difference between them is of course 2. All right, we expect that if x is even, the next one will be just add 2, the next one will be just be add 4 to that first number, because we always represent the other numbers in terms of that first number, which we usually represent as x. So if x is the first even integer, therefore the next one will be x plus 2, because it's the consecutive. So like 2, 4, 6, all right? And then the next even integer will be that x plus 4. Because if I say 2, 4, 6, 2, 4 is 2 plus 2, 6 is 2 plus 4. Okay, so that's how it is. So therefore, the 3 consecutive even integers would be represented as x, x plus 2, x plus 4. And it says the sum is x plus 2 plus x plus 4, and the sum is 252. And then we can just solve. And therefore, mental math, if you can mental math, what would be the integers?
X, 3x.
So 3x to 52 minus 6 is 248. You divide by 3.
Divided by 3. Come on.
Go ahead. Hmm.
240,
82.
Okay, so the first number is?
82,
Okay.
82, 84, 86.
All right. So, okay. So 82, 84, 86. Because if you add 82 plus 84 plus 86, you get 252. So please also take note of this consecutive kind of thing, all right? Consecutive. So sometimes even if you say consecutive odd, it's just the same, but they have, x plus, if the first number is 1, then x plus 3, x plus, and so, okay, we will talk more about it, but most of the time it's now the even that we would want to consider. Right. So, okay, let's try one and try to solve. Please solve that one. One number is 3 more than twice another number. If the sum of the two numbers is 36, find the numbers. Solve.
Number
Yeah,
is
I'll give you a minute or two to solve.
Okay.
Is 3 more
Solve
than
it, solve.
One number.
one number? Is 3 more than twice another number? Okay, it is
Is 3 more.
3 more. Another number. Okay, if the sum of the two numbers find the numbers. Okay. $11 and $14.
Yeah, I think you're right.
11 and 14.
But 11 plus 14 is 20, it's not 36. I think you're correct with 11, but the other one is not is not 14. It's 3 more than twice another number.
11 and 25.
Oh, okay. 11 and 25.
Is that right?
Yes. But just make sure you cannot just say, well, I want it 12 and 23 and 12 and 23 or no, because it should be one number is 3 more than twice another number.
We need
So
to
maybe you say first number,
change.
second number. Yeah, you can put that one. Okay, to begin with. So your first number is X, right? You always want that to be X. So how do you represent the second number? 3 more than twice that number, X.
Mm, mm,
3 more than twice that number that you represented as X.
3 plus.
How do you write that 3 more than twice?
3 plus 2x.
Okay, maybe it would be better to put that as 2x plus 3, right? Yeah, of course, 3 plus 2x is okay, Sine. But I just want to put that in how, what does it mean by 3 more than twice, okay? So you begin with 2x and then add 3. All right. And the sum of the two is 36. So that's it. So you now have x plus 2x plus 3 is equal to, so you're adding the 2, okay? 36. Yeah. Well, here sometimes you can do some guessing thing, but whenever I, with your quiz or whatever, I want you to be able to do that representation so that, you can go into what we call modeling of mathematics. And so, the actually, so you have 3x is equal to 33, right? Yeah, that's why x is 11. And so if x is 11, then other number is twice that 11 plus 3. So it's 22 plus 3 is 25. And if you add, that will be equal to 36. Those are number problems. Yeah. Well, of course, we cannot exhaust all the examples. The only way is for you to practice through your homework that you will be doing this weekend. And as I promised, I'll give all odd numbered questions. So those answers will lead you and guide you on how to go about things. Yes. So those are some unknown. Maybe in high school you even had AIDS problems and so on. But I will more concentrate more on some practical problems here because we want that application, not just. So we're doing this unknown number problems as to get use of how to translate the verbal description to a model mathematically. Right. So those are some examples of our unknown number problems. So I think it's better to deal with real world applications. So this is what I am more concerned about. So you see how, algebra, how math is used in solving real world problems. So I think let me begin with this example, and then I already have the solutions there, of course. It says a car rental agency advertised renting a Buick Century for $24.95 per day. And for every mile that you travel, you'll be having 0.29, all right, per mile, 29 cents. If you rent this car for 2 days, how many whole miles. So I'm dealing with whole miles because that's what they, even if there's a fraction, they deal with whole. That you can drive and your budget is $100. Okay, so the one that is unknown here is the number of miles that you would have traveled, because that's the one that you will multiply by 29 cents. But the 24.95 is what's that? This is the cost per day, which is fixed. So for every day that you travel, there is now 24.95 charge immediately. Even if you haven't even driven a mile, okay? Yeah, you will already be charged 24.95, but then for every mile that is traveled, then you're charged 29 cents. And therefore, my X is the number of miles, because you would have to look at how many miles should you travel in 2 days so that you will not exceed $100. That's your only budget. So we say let X be the number of whole miles driven. And therefore, the amount that, as far as the number of miles is concerned, would be, so we say even a per for every mile. So 29 cents for every mile. And therefore, it's 29.29x, which you already have the idea. The cost for mileage driven. Now, you are dealing with 2 days. So you have a fixed cost of twice 24.95. Okay. So 2 times 24.95 plus 0.29x is equal to 100, because that's your budget. So that is now our equation. So for 2 days, you would be charged twice of 24.95 and 29 cents for every mile. And you want to know how many miles can you drive on a budget of $100.
172.76.
All right. So you already did the computation. Yeah, that's it. So 2 times 24.95 plus 129x and so on, and you get 172.75. Now it's just whole miles. You don't tell the agency, I would drive 172 and 3/4 mile. They will deal with the whole mile. So how many miles so that your budget will be just within, you are within your budget?
172.
Okay, so we now have, you say 172. Of course, some people would think that you round it off, because to a whole number, 173. But the problem there is, if you will do 173, okay, let us try to do that. The original statement of the problem is whole number of miles. So if you round it off to 173, because that's 172.75, you will exceed, correct? You will exceed by 7 cents. And maybe you don't have that 7 cents. Okay. You only have $100. So checking the previous one, 2 times 24.95 is 49.90 plus 0.29. If you will put that as 173, it will be $100.07, which is over our budget. So therefore, you are correct that you would rather have even some little change, okay? Just drive it for 172 miles so that you are within the budget. And that will be, you will pay $99.78. And so the maximum number of whole miles, okay, the maximum number of whole number miles anyway is 172.
Mhm.
So you can make some decisions in the process. If ever you are renting a car, we are very, very much used to car rentals, so that you will not, of course, you can say, well, I drove a little bit more, but we just want to make the things exact. So I think that's just one example. All right, let's have another one. Okay, so that one is an example that I just want to show the real world applications. Okay, here we go.
Mhm.
And there are several questions in this problem. There are 2 cell phone companies. Yeah, you want T-Mobile or AT&T or Verizon, okay, those things, or Spectrum, that offer different packages. And so you want to make some decisions there. And so you go to one company, it says that company A charges a monthly service fee of $34, which is fixed, plus 0.05 per minute talk time. Company B charges a monthly service fee of $40, that's fixed. But the amount of minutes talk time per minute, the charge per minute talk time is only 4 cents. So we want to make a decision on which will you use depending on the number of talk time that you would use when you use your phone. So we want to know which company offers the better plan. And so we want to write a linear equation that models the packages offered by both companies. So how would you write? Okay, so the company A, what would be your algebraic expression for the charges of company A?
It's
What will be
30
first? What will be our unknown? Our unknown will be the number of
minutes.
talk time minutes, right? Okay, so give me what would be the charge of company A?
34 plus
Okay, that's it. Plus.
0.05x.
All right. Company B would be, so that's easy because it's very clear. 34 plus. Okay. So company B would be
40 plus 0.04x.
okay, that's it. So for company A, 0.05x, okay, that's 34 plus, but sometimes we just want to put the x, it doesn't matter, but really it's 34 plus 0.05x. And then for your B is $40 plus 0.04x. Except that, the reason why at this point we are putting 0.05x plus 34, sometimes we just want to make it as an equation where you start with the variable before the number, okay? So that will be now 0.05x plus 34. If you write 34 plus 0.05x, that's still correct. Because that's the way 34 plus. So we're now saying that your company A, the variable cost, okay, is bigger, but the monthly charge is smaller. For company B, the monthly, the fixed fee is higher, but the variable cost per minute of talk time is lower. So we'll now move on with, maybe you're still copying, but anyway, for letter B, we're saying, what if you as a person, you do a lot of talking, okay, of calling, right? And each month, you have an average number of minutes of 1,160 minutes. So your question is, which company offers the better plan? Is it company A or is it company B? If you want to guess, which one do you think?
Company
Guess.
B.
Okay.
Company A.
So company A is a better plan or company B?
Not for B.
No, it's because it's less.
Mm-hmm.
You
B.
spend so much minutes.
Mm-hmm.
Yeah,
It's B is
B should be
cheaper.
cheaper.
Because the variable cost is lower. Is that what you're thinking? All right. So then maybe I would want to say now, show that it is so. Okay. That it is really the company B, if ever, or it's company A. Okay. So let's move on to the next one. So we want to know the average number of minutes used each month is 1,160. Which company offers the better plan? So you have now that equation for A and for B. So it's just a matter of substituting, right? So you just substitute X, 1,160 minutes. So how much will you get if for company A? How much will you pay if you have a talk time of 1,160 minutes? Yeah. So here you will need some calculator if ever. Okay. All right. So I'll go back. A, so you know, 0.05x times 1,160 plus 34. For letter B, 0.04 times 1,160 plus $40. Okay, you can remove that 40, that dollar sign. So how much will you pay to company A with 1,160 minutes?
Company A would be 92.
$92.
And for B?
86.4.
Okay. So for company A, you will pay $92. But for company B, 86.4. Reason is because, of course, the variable cost for company B is much lower than company A. So if that's the way it is, you have an average number of minutes used this month for 1,160, then you know that you will just be paying 86.4 or less, depending on maybe a little lower. Okay, now, so I think you expect that for if your average number of minutes each month is only 420, so you would expect that the company A might have a lower cost because you only would be using each month 420 minutes talk time. So if only 420, how much will you pay company A?
55.
And for company B?
56.8.
Wow, that's a big difference. Okay. So, oh no, it's not 36, it's 56.8, right? Yeah, 56.8. It's not really a big difference, I should say. Well, 55, 56.8. So you are now saying, I think company B seem to be a little better. But anyway, if you only have really less than 420 minutes talk time, then you better decide on company B. Company A instead of company B. Now, letter D is more interesting. How many minutes of talk time would yield equal monthly statements from both company? The word is equal. So what will you do? How many minutes of talk time would yield equal monthly statements from both companies?
Say
Equal both the equations.
So what will be our what will be our equation?
to be it's the same equation, then you substitute, now you're calculating x.
All right. So you now equate, okay? In other words, you're saying 0.05x plus
Right.
34 equals, right?
Yep.
0.04x plus 40. And correct your solve for x. So solving that, what will be, yeah, if you have that number of minutes of talk time, then you will pay the same for company A and as well as company B.
Number.
Huh?
What's your answer?
I got 600.
So that's 0.01x equals to 6, right? So 0.05x minus 0.04x is 0.01. 40 minus 34 is 6.
600.
Divide 6 by 0.01. So did all of you get 600? And the amount that you will pay would be $64. So it appears that if you will have more than 600 minutes talk time, better use company B. If you have less than 600 minutes talk time, then you can just use company A. Isn't that okay? Because that's now the threshold, 600 and above or 600 and below. But for 600 minutes talk time, you'll pay the same amount for both company A and company B. So we use math for some decision making, especially when you want to do some budgeting. Yeah. So I think that's one application. Yeah, you are supposed to be writing an essay of about 2 pages or so on applications. Maybe you can, it's not just because when I say it's in your career, even if in your career you are doing some budgeting, and therefore doing budgeting is a very important, you need to have a very good understanding of algebra to be able to make a correct budget. Okay? Yes. Oh, here we go. Yeah. Suppose someone gave you $100,000. So also on investment, okay? You want to do investment.
100,000.
You want,
Oh,
you know, when you just put your money in the bank, savings, they will give you for $10,000, they give you 30 cents a month. Okay. Now, they offer what we call certificate of deposit or CD. Okay. Now, Mary inherits 100,000 and she invests it in 2 CDs, 2 certificates of deposit. Now, one CD pays 6% simple interest annually. The other certificate of deposit pays 4.5% simple interest annually. Now, at the end of the year, the $100,000 had an interest of 5,025. Okay, but that year. So question that is asked is, how much did she invest on the 6% interest CD, and which one, how much did she invest on the 4.5% interest CD? Yes. Okay. So all right. You remember, I hope you remember the simple interest formula.
I do when I hear it.
You remember that? I is equal to PRT. Yeah. Well, you have P, which is the principal, the amount that you invest. Okay. Your R is your interest rate. And the interest rate is usually changed. The percentage should be changed into decimal, of course. And your T is the time in years. So if we are now dealing with only 1 year, then your formula will just be I is equal to PR, right? Because if that is for 1 year. Reason is your T is already equal to 1. Okay. So we now say let X. Let me begin with that. Let X. What do you want? Maybe we'll begin with the amount invested at 6%, okay? The amount invested at 6%. How will I represent the other amount? If the total amount invested is 100,000. If X is invested at 6%, how much will be invested at 4.5% if the total is 100,000?
Why don't you just put everything on the formula and substitute?
What formula?
I mean, we can use
We'll use the formula later, but we need to represent, because what you want to know is how much was invested at the 6% CD and how much was invested at 4.5% CD. So the first thing that we need to do is to represent those two amounts of investment. So if your the amount that you invested at 6% is X, and the total is 100,000. How much is invested at 4.5%? This is X. The total is 100,000. How much is the other number?
Total is 100,000.
Divided by
Total. We say total. Are you using divide? Are you using...
5.
Okay, like if I have 10, okay, the total is 10. If one number is 2, what's the other number?
5.
No, 10. I'm saying 10. One number is 2. What's the other number?
8.
8. Okay. How do you get 8? Out of, if you know 2.
If you
Total
know
minus.
2, then you subtract.
Yeah. So you say 10 minus 2 is 8. Okay. Therefore, how do we represent the other amount? If one of them is X, the other number will be what if the total is 100,000?
It will be 100 minus X.
All right. So it should be 100,000 minus X. That's the amount invested at 4%. Are we okay? Or you will now say the other number, because we only want one variable. Maybe later on when we now have systems of equations where you now can have X and Y, then you can just say let X be the amount invested, then Y will be for the other one, but the idea here is that we want only that the variable is X. So is that clear? That if you have the sum, so please remember that. If you have the sum, and you represent one as the other, X as the one number, the second number will just be the difference, okay? So it will now be your total minus that other number. So if I say the sum is 32, if X is the other number will be 32 minus X. So yeah, okay. Now, okay, so we now deal with interest, because we know the interest is $5,025. So the first thing we'll have to do is how much interest will be obtained when the interest is 6% for that investment X. So the interest is, okay, we said I is equal to PR. So the interest for 6% will be the principal, which is your X, times your rate, which is 6%, which is 0.06, right? Because we changed that to decimal. And therefore, for that 6%, your interest will now be 0.06x. That's interest 1. Now, for your interest 2, 4.5, sorry, that's not 4, 4.5. The principal is 100,000 minus X, and multiply that by your rate, which is 0.045, right? Principal times the rate. That's I sub 2.
It's not 4.5?
Yeah, you change it to decimal.
Because it's 4.5%.
Divided by 100, or you move to 2 decimal places to the left. You remember that? Changing your percent to decimal. So that's why 6% is 0.06. 4.5% is 0.045. And so it says the total interest is 5,025. So you will now add I sub 1 plus I sub 2. And I sub 1 is 0.06x plus. Okay, what is now 0.0? Can you please do that? 0.045 times 100,000?
No.
How many 3 decimal places? Okay, move.
4,500.
All right, so it's 4,500 minus 0.045x. Okay, so 0.06x plus 4,500 minus 0.045x, which is now your interest for the second CD. The total is 5,025. Solve. What is x? Use calculator. This is one thing with when it's only algebra, you don't need calculator. But for real world problems, we need some calculator here. You transfer 4,500 to the other side, 0.06 minus 0.05x, then divide. How many? How many
30
thousands?
35,000.
35. All right. So you're now saying the one that was invested in the 6% is 35,000. Then what was invested on the other deposit? You just subtract, right? 100,000 minus 35,000 is 65,000. So there may be a reason why she used first she invested on only 35,000 with the one that is paying 6%, because sometimes, you know, when the interest is more, the risk is more. I think you know that in banking, the higher the interest, there is a higher risk. So she decided to just invest 6% for the 6% CD, 35,000, and 4.5% for the 65,000 for the 4.5% simple interest. And when she did that, the total amount that she got for that year is $5,025 for her $100,000 investment.
So
Yes,
said 35,000 for which one?
for the 6%, because that's the X. This one.
I got x equals 5,000.
Try that again. 0.06 minus 0.045.
I did plus.
Okay, yes, you're subtracting. Right. That's 0.015. Then you have 5,025 minus 45 divided by 0.015 gives you 35,000. Is that okay? Yeah, it's a minus. So.
Probably.
Try that again.
525.
So you have 0.06 minus 0.045x is 0.015x equals 5,025 minus 4,500. And divide both sides. After subtracting, divide both sides by 0.015. Then you will now get 35,000. Okay. And then for the second one, you just subtract 35,000 from 100,000. 100,000 minus 35,000, 65,000 for this other one the interest of 4.5%. So some people would want to take the lower risk. You invest more on places where you know there's no scamming or something like that. Oh, sorry for my writing. I hope you're able to understand. So it's kind of difficult. Sometimes my pen is.
So at each rate, it's 335,000.
What is that, Sine?
No, I was asking at each rate, it's 335,000 that is invested.
35,000 is invested in one place, so you just
Yeah.
subtract 100,000. So 100,000 minus 35,000 is 65,000.
65. Yes. 100,000 minus 65,000.
The 4.5.
So what you do is for the second number, you just use your representation. So if your X now, we found 35,000, the other number was represented as 100,000 minus X. So 100,000 minus 35,000. So you now say that she invested 65,000 at that bank that offers 4.5% interest per annum for CD. But then she invested 35,000 at the bank where the interest is 6%.
5.
And so you can actually substitute 35,000 times 0.06x, okay? Then 65,000 times 0.0545x, you'll find that the answer is 5,025. If you want to check.
50,
525.
Uh-huh.
0.
35,000 times 0.06, you then 65,000 times 0.045, you add the two, you'll get 5,025 as the total interest per year.
5,
Minus 500.
25, 25, 0, 22, was it 0.01?
I erase the whole thing. So at least for checking, what we can do is you say 35,000 times 0.06. 65,000 times 0.045. Whatever you get, and you get here, the total should be 5,025 for checking.
Mm.
So 35,000 times 0.06 is 2,100. Then 65,000 times 0.045 is 2,925. If you add the two, then you know. Okay, so you got your answer correctly. So the interest that she received from the $35,000 at 6% interest is 2,100. And then from the 65,000 at 4.5% interest, change to 0.045 is 2,125. And that's why the total interest that she received from those two CDs is 5,025. Okay? Nice problems. Okay. Let's have another one. I want you to just solve. This is only simple interest formula. There. Okay, that's more real. James needed $500 for his out-of-pocket medical bills. So he didn't have that money. He needed to pay medical bill. He borrowed money from his friend John and said, well, in 6 months, I'll pay you. But John said, okay, yeah, this is $500. I'm taking it from the bank. So I will lend you the money, but you have to pay an interest of 9% per annum. So per year, that's what it means by per annum. How much money will James pay John after 6 months? So it's just using a formula.
James needed 500 for his out-of-pocket medical bill. He borrowed money from his friend John, and he needs to pay after 6 months. He has 500. Okay. John loaned James the amount at an interest rate of 9%. How much money will James pay John after 6 months?
Yeah.
6 months. Okay.
So take note that your T here is years, but he will pay
Oh,
in
it's half.
just half the year. Okay, yes, yes.
Okay.
So 500.
500.
So how much total amount that
I
he will pay?
was
Of course, the total amount is including the interest.
Yeah. So we need to find
times 0.09.
Is it 22.5?
But I want the total amount. So the principal is?
522.5.
500.
Yes.
For R, you need to put 0.09.
So what you
Yeah.
are actually looking for is the amount that you will pay will be the amount that was, okay, the total amount, which I'm sorry, I'll put 500 because that was the 500 thing that was, okay, the 500 plus the interest, right? So it is now 500 plus the interest. And the interest is PRT. Okay? So it will now be 500 plus PRT. The principal is 500 times the rate, which is 0.09, times the time in years. And so you did 1/2 or 0.5, right?
Yeah.
Because 6 months is 0.5. And so you now have 500. This is a simple problem. 22.5. So at the end of 6 months, he will pay $522.50. Yes. So you would say, well, not bad. You just pay $22.50 for your $500. So anyway, let us just get some little lesson from this problem. So what is, let me ask this question. What is your concept about lending with interest?
You pay more than you.
Yeah. So in your personal, a friend borrows from you. So Bethany borrows from Manish. And Manish would say, I charge interest for the amount that you borrow. Will you charge interest, Manish?
Wow.
That's 6 months.
Because you're a businessman, okay?
I'm a business entrepreneur.
Or maybe charge a little bit more, 20%. Okay. All right, 9%. So anyway, yeah, I think you know the concept of usury, right? where you lend money at an exorbitant interest, very high interest. That we call that illegal money lending. How much is a very high interest? If you will be asked. That maybe someone would charge you interest and you say, oh, that's usury because you're charging an exorbitant rate. Sine, what amount, what percentage would you think is considered usury?
That's like, I don't know, but more than, if it's more than maybe 15%.
More than 15%, all right. Or maybe more than the prevailing interest that people would charge or something like that, usury. But let me just talk about the biblical stand on the practice of usury. Let's see, what does the Bible say? What percent is considered usury? So I just want to go back to Nehemiah's Nehemiah's experience when he went back to Jerusalem after, it was devastated or something like that. And in Nehemiah 5:9-11, this was what Nehemiah told the Israelites. What you are doing is not right. Shouldn't you walk in the fear of our God to avoid the reproach of our Gentile enemies? Now, he was talking about something that these people were doing. And he said, I and my brothers and my men are also lending the people money and grain, especially because they're poor, But let the exacting of usury stop. Give back to them immediately their fields, vineyards, olive groves, and the houses, and also the usury you are charging them. And how much is that charge that they're charging?
100th part.
The 100th part of the money, grain, new wine, and oil. So for Nehemiah, what interest is considered usury? What is 100th? How much is that in percent?
10?
100th. 100th. 1/100.
Zero.
So what percent is that? 100. When we say percent, isn't that it's a number over 100? So if it is 100, that is 1%.
100%.
100%.
1%. So in the Bible, Manish, 1% is considered usury.
Huh?
100 is 1/100, and that's percent, right? 100 is 0.01. 0.01, change that to percent, that will be 1%.
Wow.
Especially when you are lending to your brothers, to your neighbors, to your friends, for them, for in the Bible, charging interest. And imagine just 1%. 1% is already usury. So the moral, if you lend money to Sine, don't charge interest because 1% is already usury. Yes, because according to the Bible, Deuteronomy 15:7-8, if there is a poor man among your brothers in any of the towns of the land that the Lord your God is giving you, do not be hard-hearted or tight-fisted toward your poor brother. Rather, be open-handed and freely lend him whatever he needs. And I want all of you to read this. Read this loud.
It's kind to the
Whoever is
lands
kind
of
to the poor
Relent to the Lord, and he will reward them for what they have done.
Lord.
Proverbs 19:17.
All right. So that if you lend someone some amount and you don't charge any interest, you are lending to the Lord, and God will reward you for whatever you have done. Okay, some little lesson out of that, but yeah, okay. But of course, it's talking about the poor people who, like maybe John doesn't even have $500 for his out of pocket money for the medical bills. Okay, so maybe we still have, is that okay? Now can we proceed? Let's have using a formula. All right, this one is another nice thing. We're using formula. And I think, or maybe it's a little bit easier because the formula is already given, like we have the simple interest formula. So we have this problem. It takes Andrew 30 minutes to drive to work in the morning. Now, he drives home using the same route, but it takes 10 minutes longer. And he averages 10 miles per hour less than in the morning. In other words, his driving is much slower in the afternoon when he drives back home. He leaves the house very early, but then goes home when it's already rush hour, and therefore he drives a little less in a freeway or something like that. So the question is, how far does Andrew drive to work? Or we're just saying, how far is Andrew's house from his workplace? If it takes him 30 minutes to drive to work in the morning, and then when he comes back home, it takes him 10 minutes longer with an average of 10 miles per hour less than his speed in the morning. So this problem will be using the distance formula, not the distance formula that we learned where you know the location, coordinates kind of thing. But this is a type of formula that deals with the speed or the rate and the time it takes for that person to travel. Okay, so take note in this problem, the distance we're looking for is the same distance that he drives to work as well as he drives from work. Okay, so maybe it's nice to put in some sometimes you need to write this, represent this systematically. Okay. So we know that the distance, because going to work and coming back home, you will have the same distance. Okay. Yeah, because the house doesn't change its location. All right. So we will represent that distance as D because that's what we are looking for really. Now question, we need to know the rate. For us to be able to find the distance, we need the rate and the time. Okay. So if we now deal with going to work, we actually don't know the rate. All right. The only one we know is that coming back, Andrew drives 10 minutes less than his miles per hour less than his driving going to work. So we can represent R instead of X. Maybe I'll just use R because I'm using the formula of the rate or the speed of average speed of Andrew going to work. But when he comes back home, his rate is 10 miles per hour less. How do we represent that?
R minus 10.
Yes, sure. R minus
10.
10. Very good. Now let's have the time. You know the time for Andrew to go to work in the morning. And it takes Andrew 30 minutes, right? So how much time that he uses to 30 minutes? But take note that our rate is miles per hour. We need to be consistent with our unit of measure. So if we're using our rate as 10 miles per hour, therefore our time should also be in hour, okay? I think that's much easier to change rather than change the 10 miles per hour to 10 miles, 2 miles per minute. So if it's 30 minutes, we change that to hours, okay? So therefore, the time it takes for Andrew to go to work is 0.5,
Five.
right? 0.5, 30 minutes. And it says, when he goes back home, it takes him 10 minutes longer. How much time does he use to go back home in the afternoon? 10 minutes longer. So if it's 30 minutes going there, 10 minutes longer would be
40 minutes.
40 minutes. And 40 minutes in hour would be over 60, right?
So that's how you represent.
Okay, so change that just maybe in fraction. 40 over 60 is how many?
66.
0.6.
66, or can I just, okay, maybe we better use fraction so that we don't want, because the 0.66666, that one will be too many 66666, okay? So let us just make this as 1/2
One of the
and
two.
2/3, right? Is that 1/2 and 2/3?
Mm-hmm.
Yes. Okay. So we'll now have the equation. So what will be the equation of the distance traveled to work? It's rate times time. So the distance to work is 1/2 hour. Is that okay?
Mm-hmm.
Rate? But I want the R to be at that other side. It's actually R times 1/2. Are you fine? Using this formula. Distance. I'm saying how much is the distance to work? Equation, distance to work. Okay? So is it okay that it's 1/2 times R?
Yes.
Yes. How about the equation of your distance going back home?
R times 2. R times.
The rate is R minus 10 and the time is
2/3.
2/3. Okay. So I think so that it's easier, I'll just put the 2/3 out. Anyway, they are commutative. R minus 10. Is that fine?
Mm-hmm.
Now, as I said, the distance traveled would be the same, going home and going to work. So we now equate so that we can solve for R, and once we are able to solve for R, we can find the distance. Let me erase that other side so that we have enough space. Yeah, because this one is already clear. So we equate. The distance to work is the same as the distance coming back home. Distance is equal to distance. So you now say 1/2 R is equal to 2/3 R minus 10. And you say, why are we looking for R? All right, because that's the one that we are able to represent. Because once you know your R, you can find the distance. Solve for R.
Forty.
Okay, very good. Now you need to tell me how much is the distance. Okay, so anyway, I think what you did was 3R is equal to 4R minus 10, right? We cross multiply because they have the common denominator for the one side, common denominator for the other side. we actually multiply by 6 each one, but you can cross multiply, all right? And therefore, you now have 3r minus 4r is equal to minus 40, okay? Minus r is equal to minus 40, r is equal to 40. Good. So, how much is the distance? How much does Andrew drive to work? I mean, no, yes. How far? Not how much, how far. So, what's the distance of Andrew's house from his workplace? You can substitute to any of these equations. But I think the easiest way to substitute is
Distance is half of so 20.
20. All right. Any of those equations will do. But the easiest way to substitute is in that distance to work, which is 1/2 r. So the distance is equal to 1/2 r. The distance that he drives to work is 1/2 times 40, which gives you 40 miles. It's good to put the unit of measure. Okay? I'm sorry. Why did I put 40? That
20.
one is 20. Okay. 1/2 r is equal to 20 miles. If you substitute r minus 10, okay? 40 minus 10 is 30. Divided by 3 is 10. Times 2 is also 20. Because the distances are the same. So Andrew drives 20 miles going to work. No, that's too far. Yeah, but there are people who would really live 20 miles away from their workplace. Okay, so I think, yeah, there's no more time for another problem. I'll end here. I will just post on the bulletin board the exercises that you will work on this. Yeah, you have a weekend to do. Practice. It's important to really practice. Okay. So you'll practice some real world applications, number problems, and other types of problems which may be using a formula. Okay, so that will be all for today, and I hope you have a good time and a good weekend ahead of you. Rachel, I'll continue to pray for you. I hope that you get well soon. And all of you, please take care of yourself. Is it raining there or not? No rains at all? Okay, so at least that's good. But if ever it rains, don't be rained on.
Yeah.
Because to be rained on is one reason why we get sick.
Mhm.
Yes. All right. So bye.
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 Thank you.
Okay. Be well and